All right, let's cover the Sieve of Eratosthenes. That one's just a fun one to say. So what it does is it's going to find a prime number of a given set range. So if we give it n equals 100, we're going to find all the prime numbers from 2 to 100. If we look at our example, we can see we start at 2 and we're going to go all the way to 25. I picked 25 because we need a square root, and 25 is just an easy number to get the square root from. So what we're going to do is we're going to take the square root of 25, which is 5, and we're going to look through 2 through 5. What we're going to do is we're going to start by going through, we're going to name them all prime, and then we're going to take everything that's a multiple of 2, and we're going to remove it because it's not prime. So that's going to be 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Then we're going to move on to 3. Everything that's a multiple of 3, we're going to remove. So that's going to be 9, 15, and 21. Those are the only ones left. 4, we could go for the multiples of 4, but they've already been removed. And we're going to move on to our last one, which is going to be 5. And the only thing that's multiple of 5 left is going to be 25. Next, let's look at how we can implement that in JavaScript. All right, over here in our sieve.js, let's start with our pseudocode. First, what we're going to want to do is we're going to want to label all of them prime. Next, let's move on. We want to iterate from 2 to the square, if I can spell here, square root of n. N is going to be that number, the top of our, if we want to go all the way up to 100, that will be n. So in this case, n will be 25 in our example. Let's say if the number is a multiple of 2, once again, to the square root of n, we want to label it as not prime. And then from there, let's just return everything that's remaining. All right, let's dive into that function. Let's just call it function Eratosthenes. Hopefully I spelled that right. That's a mouthful. Okay, so the first thing we want is we want an array. And this array is going to be a placeholder. So we're going to go through and we're going to use this to hold either false or true values as our way to eliminate them out. Next, let's make our upper limit, which is going to be our square root. Math.square root, if I can remember how to write this. Let's give it n. That's going to give us our upper limit. And then let's make another one called primes. And when we're all done, we're going to push all of our numbers that we know are prime right into this array. Okay, so from here, like I said, we need to make everything true. That's our first step. We're going to label everything prime. So let's make a for loop. Let's let I equal 1. And then as long as I is less than n, so we're going to go all the way from I up to n minus 1. And then we're going to do I plus plus. I cannot type today. Okay, in here, let's just do an array dot push true. And that's simply just going to run through this entire array, and everything for the whole length of it is going to be true. Then we're going to move on, and we're going to do for I equals 2. From I, as long as I is less than or equal to our upper limit. So here's where we're going to start checking our stuff. Let's do I plus plus. Okay, so this is going to run through our 1 through 5 in this scenario. Now, a quick catch here. Let's do if array I. Let's make sure it hasn't already been ruled out like we saw with our example of 4. Let's do for let j equal I times I. I'll explain this in a second after I can kind of fumble my way through this. And j is less than n. Let's do j plus equals I. Okay, so let's say, for instance, we start at 2. 2 times 2 is going to be 4. So now we're going to set it at 4. J is going to be equal to 4. And every time we run through this, 4 is going to be 6. First, it's going to be 4, then it's going to be 6, then it's going to be 8, and it's going to be 10. So you can see we're starting to get the multiples of 2. If j was 3, we're going to say 3 times 3 is 9. So we're going to do 9, 12, everything that's a multiple of 3, we're going to keep going. And we're going to do that all the way up to our upper limit, which in the example we're going to be using is going to be 5. So we know anything at array position j is now going to be false. So this is going to rule it out. Like I said, we're going to go through, and when we go through all the 2's, 2 is going to be, or 2 is not going to be false because 2 is a prime, but 4 is going to be false. 6 is going to be false, 8 is going to be false, and that's how we're going to go through, and we're just going to kind of eliminate them out. Then, all we have to do after that is say for let I equal 2, because again, we're going to start at 2, well, I is less than n, and let's increment by 1. We now know if, so we've ruled out everything at this point. At this point, everything that's not prime has been ruled out. So if it's in this array that's true, we can do primes.push I. And now we're going to take everything that is still true, and we're going to push it into our array primes. The only thing left at this point is to return primes. Now we can give this a shot and just say console.log Eratosthenes, and let's pass it 25. Fire up my console. Let's run it. And there we go. We got our 2, we got our 3, 5, 7, 11, 13, 17, 19, 23. We got all of our primes from that number. Now, one thing that's a little not clear is going to be this. So let's take a little deeper look into this. Let's just look at what that array looks like at this point when we make everything true, because we're making this array. Let me open up my console a bit. Let's get a little closer look at that. And you can see what we did is we made an array of true. This is our range from 2 to 25. We made them all true. So now let's do the same thing. Actually, let's just leave that console log there. Did I copy that? No, I did not. Okay, and let's just console.log that array again. So we're going to have our array of all trues, and then we're going to kind of get an idea of what was happening there. Okay, so we got all our trues, but you can see we came through here. We labeled 2 true, 3 true. As we're going through them, we suddenly start labeling them false. And we can see that this is where that's kind of happening. We're labeling them false here. And then our last point, what we did right here, is we reiterated through this, except this time rather than label them false, we said if that's true, let's push it here. If that one's true, let's push it here. And we just went through them all one by one. And if it was true, we pushed them here. I hope this helped clarify a little bit about this really kind of neat algorithm here. And thanks again for watching.